Hello class, in today's video we're going to be looking at application questions related to arithmetic sequences. The learning intention of today's video is we're going to be able to represent scenarios with the explicit arithmetic sequence formula, and lastly we're going to be able to solve worded problems that follow the same pattern as an arithmetic sequence. So last lesson, we were looking at how do we actually use the explicit arithmetic sequence formula to solve problems. But in today's lesson, what we're going to be doing is we're going to be representing the actual worded problems by this particular general formula so that we can actually solve these actual problems. So before we actually do that, I do want to kind of show you one thing. So I've previously showed you this example probably numerous times already, and I said that if this is the arithmetic sequence, we can kind of like label these by using these following notations. So we can use T1, T2, T3, T4 to indicate the first term, the second term, the third term, the fourth term, etc., etc. Now, in order for us to transfer this over to our table, we can do something similar to this, where n represents the position in the sequence and Tn represents the value for that. So for instance, in this case over here, I could represent it like this. So for the very first term, it's going to correspond to a value of 3. For the second term, it's going to correspond to a value of 10. The third term will correspond to a value of 17. And the fourth term corresponds to a value of 24. Now, if you look very carefully on my particular table, you notice that the increment in your term, the term position is always going to increase by 1. We know that. So for the first term, the second term, the third term, fourth term, they just increase by 1 as you go from left to right on the table. We also know that the difference between each term in an arithmetic sequence is always going to go up or down by the same amount, which we refer to as the common difference. So in this example over here, notice that this is always going to be increasing up by plus 7. Now you're probably wondering, so why am I showing you this particular table? How is this going to help me solve worded problems? Now I'll show you what a worded problem might look like, and as you can see over here, you might think, oh wow, this is quite overwhelming, there's so much text, but I can assure you that solving these problems becomes really easy if you know how to represent all the information into a table, because in that way what you can do is you can actually clearly see what patterns are present. And we know that for an arithmetic sequence, they have a pattern where they have a constant common difference, and this is how we're going to actually figure out the formula for a worded problem and solve it as well. So remember, this is the formula over here, and what we're going to try to do usually for some of the word problems is we're going to find out what this formula is so that we can actually solve what the question actually asks us to do. So you always generally want to create a table, something similar to this. The table is never provided to you at all, but you have to create this table in order for you to solve it. So let's look at the first example. I'm going to go through 2 examples in total. So in this example up here, the exact same example before, what this square represents over here is these represents the tables, and each of those little rectangles indicate the number of students or people that can sit on that table. So we can see that for the if you have one table, this can accommodate 4 students. If you have 2 tables side by side, this can accommodate 1, 2, 3, 4, 5, 6, and so forth. So in this case over here, your variables, you need to identify what the variables are. Your variables are going to be the table number, okay, because this can change, and the number of students, because the definition of variable is things that can change over time. So in this case over here, I'm going to transfer this image into a table format. Now, when I've got one table, I can see that I've got 4 students, so therefore I'm going to put 4 here. And when I've got 2 tables, I can accommodate 6, and when I have 3 tables, I can accommodate 8. Now, once we've actually inputted all our data into our table format, what you need to be able to do is you need to identify which one of these variables corresponds to n and which corresponds to Tn, the value of any term in the position, in the arithmetic sequence, sorry. So in order to do this, what we need to do is we just kind of need to look at how much or these terms are increasing by. So in this case over here, notice that for the table numbers, they just increase by 1 each time as we move from left to right. But for the number of students, this increases by positive 2. Now, we already know from the previous example that I've shown you over here that all numbers, all the positions in a sequence kind of shift up by 1. So from the first number to the second term, this increases by 1 each time. but the difference between each term number, between each consecutive term number, increases by the common difference. And because this increases by a common difference of +2, therefore this indicates that the number of students equals to Tn. I'll probably explain that pretty poorly, but I think if you guys go through multiple examples, I think you'll understand what I mean by this. So in this case over here, the number of students represents your Tn, whereas a table number represents n, the number, the position within the sequence itself, because it increases by 1 each time. And once we've got this information, now I can actually derive what the formula is going to be. So this was the general formula of the explicit formula. So what we need to do now is just substitute all the values in. We know that the T1 is the value for the first term. In this case over here, that's going to be equal to 4. So T1 is equal to 4. The common difference in this example is that the number of students increases by 2 each time. So therefore, common difference equals to +2. Just substitute this into your formula. So if you substitute this into your formula, this is going to be your general equation that summarizes this particular pattern over here. So if you answered question 1 already, now we can answer question 2. So question 2 says, use the general formula to determine how many people can sit around 12 tables. So they've given us the table number already. So they've given us this. We want to find out what this is. So what we're going to do is we're going to substitute the number of tables as 12 into the formula. So wherever I see n, I'm going to substitute 12 into that. So therefore T12 is going to equal to 4 plus 2 bracket 12 minus 1. Put this into your calculator, you're going to get an answer of 26. So therefore, this means that 26 people or 26 students can actually sit on 12 tables when it's side by side. And for the last question, how many tables are needed to sit 20 people? So in this case over here, we're trying to find out what this value is. And remember in the last lesson, I've shown you this particular formula over here. So we're going to be using this formula to actually solve this problem. So in this case, 20 people is the value in this case over here. So that's going to be the value of Tn. So 20 minus 4, which is the initial, divided by 2, plus 1. If you do this correctly, you're going to get an answer of 9, meaning that you need 9 tables to accommodate 20 people. So that's the first example. Don't be too afraid if you didn't really understand much going on here. I think in the second example, I think this will really help you. Now, in our second example, it reads, there are 125 passengers in the first carriage, 150 passengers in the second carriage, and 175 passengers in the third carriage, and so forth in an arithmetic sequence. What's the total number of passengers in the first 7 carriages? Okay, so whenever you're doing this question, always create a table. The table is generally never given to you at all. But firstly, let's identify what are the variables for this particular question or this particular example. In this case over here, your variables are going to be the number of passengers and the carriage number. So we're going to put it into a table, something similar to this. Once we do this, then we're going to start extracting the actual information from the question into our table. It tells us that in the very first carriage, this can fit 125. So you'll put your data something similar to this. In the second carriage, this can fit 150 passengers. And in the third carriage, this can fit 175 passengers. Once we've identified and put all the information into our table, we need to identify which one of these variables corresponds to n and which one corresponds to Tn, okay? Now, remember that as you go from left to right, the one that goes up by 1 every single time is going to be n, because that's the position within the arithmetic sequence. It always increases by 1 each time. So the first term, second term, third term, etc., etc., that's going to be n. So therefore, in this case, it's going to be pretty straight obvious that the carriage number represents the n, and the number of passengers is going to represent Tn, because they go up by the same amount, a constant common difference of 25 in this case. So once you've identified that, then you can actually start answering the question. The question asks us, what's the total number of passengers in the first 7 carriages? We've already got the number of passengers for the first 3. So what we need to do is pretty much extend this table to 7 and find out how many passengers can fit in the 4th, 5th, 6th, and 7th, and add up all those values together. So because we know that the common difference goes up by 25 each time, I therefore know that this is going to fit 200 passengers in the 4th carriage. The next one's going to be 225, 250, 275. And once you filled out this particular table over here, then you can start answering this question. Notice for this particular question, I didn't really need to write the general formula. I can still answer this question without doing so. And if you can, then you don't have to. So in this case over here, because I want to find out the total number of passengers in the first 7 carriages, I want to add this all together. So if you add up all the values together, you're going to get an answer of 1,400 passengers. Alright guys, what I'd like you to do right now is I'd like you to please attempt this question over here. So the question reads, the Greek theatre shown at the right has 30 seats in the first row. So the first row meaning this whole thing over here. And each row behind the first row gains an extra 2 seats. How many seats are in the 5th row? So for this particular question over here, you will need to create a table as well as a general formula. Please pause this video right now, give yourself 5 minutes, and then compare your answers with my answers. If you did this correctly, then this is what you should have got. So firstly, we're identifying the variables for this question. So there's the seat, the number of seats is going to be one of the variables, and the other variable is going to be the rows in this case. So if you do this, this is what you should get if you extracted all the information into your table format. Once you've done this, then it's going to be quite easy for you to generate your general formula. So in this case over here, we know that the common difference is going to equal to 2 because it increases by 2. And your T1, your first value, is going to be equal to 30. And all you need to do is substitute that into your formula. So this is what you should have as a general formula. Because this question wants us to find out how many seats are in the 5th row, we're trying to find out what Tn is when n is equal to 5. So therefore, substitute n equals to 5 into your formula. If you do that, this is what you should get, and therefore your answer is going to be 38, meaning that you can fit 38 seats in the 5th row. Alright guys, what I'd like you to do now is I'd like you to answer these 3 questions. So it shouldn't take you too long at all. There's not many questions related to this. Have a go, and if you've done this successfully, then these are the answers that you should be getting for each of these questions. Please show full working out. And if you've done all this, then I'd like you to please tackle this extension question over here. This is pretty much a very similar question to the one that the very first example we looked at. This is pretty much the end of today's video. Thank you guys for watching. Please submit all the work for this week to me, to my email. I'll see you guys again in the next video. Bye.